When you think about luxury, what comes to mind? Probably not ancient, single-celled organisms, right? Well, it turns out they have a lot more in common than you might think. We're going to unpack the surprising science behind what makes something luxurious.
So let's start with something we can all relate to. Ice cream. What actually makes a scoop of ice cream a luxury product? Is it just that it costs a lot? Or is there something else at play here?
Well, if you look at the research, especially into high-end foods, you'll see that today, luxury is so much more than just a price tag. It's really defined by things like, having rare or unique ingredients. It's about how it's made. Natural production methods are huge. Even sustainability and being eco-friendly plays a part. Basically, it's about the whole experience, something that feels special, maybe a little rare, and made with real care.
Okay, so that brings us to a really interesting challenge, especially for people innovating in the food world. Think about it. You can get natural reds, yellows, greens. That's all doable. But a truly natural, vibrant blue? Now that's tough. For the longest time, that was like the holy grail of natural food coloring.
And that's the challenge that kicks off our whole story today, a quest for that natural blue. It's a journey that's going to take us from something as simple as a dessert all the way into a high-tech lab.
So where does this incredible color come from? You might be thinking maybe a rare flower or some kind of exotic mineral from the deep sea. Nope. The answer is actually microscopic algae. Yeah, one of the oldest forms of life on our entire planet.
So let's meet our hero. Its scientific name is Arthrospira, but you've probably heard of it by its more common name, Spirulina. And yeah, while most of us know it as a superfood you put in smoothies, it's also a tiny, natural factory that churns out some incredibly valuable stuff.
And the grand prize inside this little factory? It's a molecule called Phycocyanin. This stuff is a brilliant blue pigment, and it's the exact thing scientists and food companies have been looking for. The big question, though, is how do you get it out, and how do you do it efficiently?
And that question brings us right to the core scientific problem here, how to unlock this pigment. I mean, getting this blue gold out of the algae is not easy, and it's definitely not cheap.
The researchers who did this study said it best. The whole process needed to be, in their words, business viable. So this wasn't just science for the sake of science, there was a real economic driver here. They had to figure out a way to make this whole thing profitable.
So, the scientists rolled up their sleeves and got to work. They used these incredible high-tech algae farms, they're called photobioreactors, and a whole setup of precisely controlled LED lights to run their experiments. The goal was simple, really. Find the absolute perfect recipe of conditions to trick the Arthrospira into making as much of that amazing blue stuff as it possibly could.
And what they found, well, it was something nobody expected. It was completely counterintuitive. It was a breakthrough that all came down to red light.
300%. That is how much more blue phycocyanin the algae produced when they were grown under only red light. I mean, think about that. To get more blue, you don't shine blue light on it, you shine red. How wild is that? That is a classic eureka moment right there in the lab.
And the data just makes it so obvious. Take a look. Under normal white light, the concentration is tiny, about 0.007 grams per liter. But then, look what happens when you switch to just red light. It shoots up to 0.028. That's not just a little bump, it's 4 times higher, a 300% increase. Just a massive, massive improvement.
Okay, so the science is super cool, right? But what does this actually mean in the real world, for a real business? That's where we get to the true value of this blue. And we see how we go from a lab pigment to actual profit.
And look, this stuff isn't just some run-of-the-mill food coloring. Its price goes through the roof depending on how pure it is. So for just regular food-grade stuff, it's pretty affordable. But once you get to the super pure analytical grade that's used for scientific research, we're talking more expensive than gold. Seriously.
So here is the bottom line, the business case that this one discovery makes possible. With the old white light system, you get a standard yield, standard profit. Fine. But with this new red light system, boom! You get a 300% higher concentration of a super valuable pigment. And what does that mean for the bank account? It translates to almost a 400% increase in profit. That one little scientific tweak completely changes the game economically.
But really, this story is about so much more than just one cool color or one fancy product. Let's zoom out for a second and look at the bigger picture here.
The kind of sustainable future that this kind of science points to. It's way more than just a color.
I mean, this whole journey of phycocyanin, from a simple idea like I want blue ice cream, all the way to a high-tech bioprocess, it's the perfect case study. It's a fantastic example of sustainable, nature-based innovation. It's about working with nature to create something valuable, instead of just taking from it.
And the potential here is it's huge. This blue pigment is really just the tip of the iceberg. We can use algae for bioremediation, that's cleaning up heavy metals from wastewater. We can use them to create new medicines. We can develop sustainable biofuels, and of course, use them as a great source of protein. The list of applications just goes on and on.
The source material really hits the nail on the head. It says that these tiny organisms are being used more and more as natural, sustainable resources. And this isn't some far-off, futuristic idea. It's happening right now. It's a growing field of science and industry that's offering real solutions to some of our biggest global challenges.
And so, our journey is complete. We've gone from a single cell all the way to a luxury product. It really makes you wonder, right? What other amazing secrets are hiding down there in the microscopic world, just waiting for the right conditions, maybe just a flash of the right color light to completely shape our future?